Hello, in this video, we're going to talk about conservation of energy, which is sort of an accounting for energy. This video assumes that you have knowledge of different forms of energy. And so if you haven't already watched my video on different types of energy, I'd recommend watching that first. First off, what are our content and language objectives? Our content objective is I can solve conservation of energy math problems. Language objective is I can write my own conservation of energy equations. So conservation overview, what is conservation of energy? The law of conservation of energy states that energy can be neither destroyed nor created, only converted from one form to another. And so if you started with a ball above the ground and then dropped it, you'd begin with potential energy. You'd end up with kinetic energy. But again, energy can't be lost or gained. It's just turned from one form into another. Law of conservation, again, it says that your starting energy is going to equal your ending energy. Just a conservation example, this whole video is just going to be solving an example from start to end. It says a 1 kilogram ball is dropped from 22 meters. If the ball is traveling 7 meters per second, 12 meters above the ground, what is the force of friction that's acting on this ball? To go through and solve conservation of energy equations, my recommendation would be to start with determining what types of energy you have at the beginning of some scenario or at the start of some scenario, and then what type or types of energy do you have at the end of this scenario. So to begin, what you have is a ball that is off the ground, and what you're asked to solve for was what is the force of friction. So you begin with an object off the ground, you begin with potential energy, and you have some force acting on the ball. At the end of this scenario, what you have is a ball that is moving 7 meters per second, and you have a ball that is still off the ground. It hasn't hit the ground yet. It's still 12 meters off the ground. And so what you need to do is you need to write a conservation of energy equation. This is the most difficult part, is you sort of have to write your own equation. And so what we have is energy potential energy, minus work, because you're being slowed down due to friction, equals energy potential plus energy kinetic. Why? Because again, you start with a ball off the ground. You're losing speed, is what we'll hopefully find, due to friction. You end up with a ball off the ground, and you end up with an object that's moving at the end of this scenario. So the next step would be to take each of these different values, different types of energy, and plug in the different equations for energy potential, for work, for energy kinetic. And so energy potential is mass times gravity times height. Work is force times distance. Energy kinetic is 1/2 times mass times velocity squared. At this point, what you can do is just plug in the values that are given to you in this problem. And so I'll walk you through that. Step one, mass times gravity times height. For the first scenario, I just used a mass of 1 kilogram that's given to you in this problem. Gravity, I just used 10 to make the math a little easy. You can use 9.8 if you prefer. And then height is 22 meters in the picture that's shown here and in this scenario itself. Next, you're asked to solve for work, which is force times distance. You're asked to solve for what is the force of friction. And so I'm just going to leave that as F. The distance, you start at 22 meters off the ground. You end up at 12 meters off the ground. And so you have this force of friction that's acting over 10 meters between 22 and 12. You end up with the ball that's still off the ground. Potential energy is mass times gravity times height. And the object's moving. And so kinetic energy is 1/2 times mass times velocity squared. When I start to work through this problem and just find the product of each of these different things in the parentheses, what I find is that 10F, rearranging this equation, adding, subtracting, multiplying, dividing, is equal to 75.5. I left out all units just so you can sort of see what I'm working with here. And so the force, the value that I come up with here, is 7.55 newtons. That is the force of friction that's acting on the ball. So how do you go through and solve these sorts of problems? One, you have to determine the types of energy you have before and afterwards. So ask yourselves the questions, is the object off the ground? Is the object moving? Is there some push or some pull? Is there some spring involved? Do that before and after, at the beginning of a scenario and at the end of the scenario. Using that information to write your own conservation of energy equation. And then 3, what you need to do is plug in all the values that you're given. There should be one value that you are not given that you can use to solve for your answer. That is the end of this video explaining how to solve conservation of energy problems. If you have any questions, again, review the video on types of energy. As well, you're also welcome to stop by during our homework help times or period 1A. Thank you very much and have a great day.